Hello everyone, welcome to the Mercury Virtual. Hope you are doing good. Today I'm going to start with a new topic, new chapter, that is chapter number 11, Concurrent Programming. In the last class I have finished with the last chapter, that is very easy chapter, that is the system level input output. Means what are the input and output that is available for the system, that is at the system level what are the inputs and the output that is available, that is system level input output. Now today I'm going to start with a new topic, that is concurrent programming. But before this, let's take a quick review of the previous class, that is what is covered or what we have covered in the last class. In the last class we have covered about the system level input output continued, that is continuation of the chapter, that is the system level input output. We have covered the topics, that is the RIO, that is robust input output package. So whenever there is any short counts that are removed or that are maintained by using the RIO package. So this is RIO is a set of wrappers that provides efficient and robust input-output in applications such as network programming that are subject to the short counts. As I said, or as I told you, that RIO is a set of wrappers that provides the network programming or that provides the network programs that are subject to the short counts. RIO provides two different kinds of functions that we have discussed in the last class. One is unbuffered input and output that is run by using the RIO read-in, and RIO write-in. And another function is the buffered input of binary data and text line that are done by using two functions. One is RIO read line NB and one is RIO read NB. So these are the two functions that is available in the RIO package. One is unbuffered and one is buffered, and unbuffered contains another functions and the buffer contains another two functions. Then we have covered what is RIO package, and in detail what is the unbuffered RIO input and output that is used for reading and writing. So two functions are used, one is used for reading and one is used for writing. This is the example. Then we have discussed about the RIO buffered RIO input functions. Means what is the meaning of the buffered input output or buffered input functions, that is a buffered RIO input function that is generally or basically used for reading the text line and the binary files. That is, it is used for reading the text line and the binary data for a file that is generally or that is partially cached in an internal memory buffer. We have discussed one example also. This is the example, or these are the explanation of the example. Then RIO example. We also covered one RIO example so that you are able to clarify the concept of the RIO. Then next topic that we have covered is file metadata. That is any data, means data about the data is known as the file metadata. That is the metadata. In this case, this is a file metadata that is maintained by the kernel, accessed by the user with the facility to maintain by using two functions. One is stat function, one is abstract function. So two functions are used, one is stat, one is abstract function for maintaining the metadata. Then this is the example how to access the file metadata. Then how the UNIX kernel represents the open file, that we have discussed that what is the scenario or what is the outcome, that how UNIX kernel or the kernel in the UNIX represents the open file. This is the next topic that we have discussed. Then next what we have discussed is there are two or the file options that is available. One is used for a descriptor, that is the kernel uses the descriptor. One is used for representing the open files. Then descriptor 1, that is stdio or out, is used for representing the variable, as well as the descriptor for points to open the disk files. Then we have discussed about the next topic, that is a file sharing. That is how file will be shared among the different processes among the different disks. That is a file sharing. So this says two different different descriptor, that is a file descriptor, share the same file, shares the same disk file through two different open entries. That is done by using the file sharing. Then we have discussed with the help of the a diagram, with the help of the example, that is how file will be shared, that is how file sharing is done in an operating system. Then how to process, or how process of different processes shares the file. Then input output redirection. We have discussed the next topic, that how one input is, or one output becomes the input for the another. That is used by using the function, that is the function name is dup2, that is dup2, that is duplicate 2. In this two arguments are used. One is your old FD, one is your new FD. So old FD is used for the old file descriptor and the new FD is used for the new file descriptor. So two functions are used, one is old FD and one is new FD. Then this is an example that we have discussed about the input output redirection, that is used by calling the dup2 function. That is a dup2 function that is used for the std out and std in. Then this is the example that we have discussed. Then at last we have discussed one important topic, that is standard input output functions. Means what are the standard input output functions that is available in a C programming language. That is C maintained, or C standard library maintains some high level standard input output functions. Example includes, or example of the standard input output function includes opening and closing the files, reading and writing the bytes, reading and writing the text lines, formatted, reading and writing. So how the standard input output function will be opened? By using the fopen function, as well as how it will be closed by using the fclose function. So for opening this is used, that is fopen. For closing it is used, that is fclose. In the same way, reading fread, writing fwrite. Text, for text line this is fgets, fputs. In the same way, how to format by using the scanf and the printf. Then we have discussed about the standard input output streams. That is what is a stream and how it will be available in a stream. That is whenever we contain, or whenever we combine the file into a multiple files into a one place, that is known as the stream. That is abstraction for the file descriptor and a buffer in a memory. So this is the memory location where all the data is available in the memory, that is known as the stream. So C program begins the life with three open streams. One is std in, one is std out, one is std error. So three streams are used. One is used for input, one is used for output, one is used for error. Then buffering in the standard input output. That is how buffer will be maintained, or how buffering is done in the standard input output. Then next what we have discussed is how to use the standard input output buffer in the action. That is how to use this in action. Then we have we have discussed the comparison between the UNIX input output, standard input output and the RIO. Means which method is the best, whether should I use UNIX input output, or should I use the standard input output, or should I use the RIO. So this says standard input output and RIO are implemented using low level UNIX input output. Then this is the scenario, that is fopen, fread, fscanf, scanf. This is used. This is the standard input output function. This is the RIO function. This is the UNIX input output function. So this is the C application program. Now then we have discussed about the what are the pros, that is what are the advantages and disadvantages of using the Unix operating or Unix input output. Then we have discussed about the pros and cons of the standard input output, that is what are the advantages and what are the disadvantages of using the standard input output. This is the continuation of the pros and cons. What are the restrictions and how to deal with the restriction, means what is the solution for these restrictions. Then choosing the input output functions, that is how to choose the input output functions. What is the scenario, what is the main motto for choosing the input output function. This is a general rule, that is use the highest level, use the maximum level input output functions you can. So this says many C programmers are able to do all of their work using the standard input output functions. So this is a scenario, this is a comparison. When to use standard input output? When working with the disk or the terminal file. So when working with the disk or any terminal files, then always use the standard input output functions. Then when to use the Unix input output? When there is a file metadata, then it's efficient or it's good to use the Unix input output. And when to use the RIO package? Whenever there is a network socket or the pipes. So this is a comparison. So whenever there is a terminal file disk, use the standard input output. Whenever there is a file metadata, use the Unix input output. And whenever there is a network socket, use the RIO. So that's all for yesterday's session. Now let's start with the new session, that is the today's session. This is a today's session, that is the concurrent programming. I'm going to start with a new chapter, that is chapter number 11, concurrent programming. And these are the topics that is available in concurrent programming. First of all, understand the concept of concurrent programming. So if any process or more than one process are executing at the same time, that is known as the concurrency. Means any task that is executing at most one, that is executing in a more than one manner. That is if there are if there are four processes and all the four processes are executing at the same time, that is known as the concurrent. So concurrent programming means more than one programs are using or are used in a concurrent way, that is a concurrent programming. These are the 8 topics that is available in this chapter. First topic is concurrent programming with processes. That is there are multiple processes which are executing at the same time or executed at the same time, that is known as the concurrent programming with processes. Next one is concurrent programming with input-output multiplexing. That is input-output multiplexing is used and more than input-output, that is more than one input and more than one output is given, that is known as the input-output multiplexing. Then concurrent programming with threads, that is how to use the concurrent programming with the thread concept. Then how to use the shared variable in a threaded program or how to share the variables. Then how to synchronize the threads with the semaphores, that is how to synchronize various threads with the semaphores that is used. Then how to use the threads for the parallelism, that is what is the concept or how to use different threads in a parallel way, that is using the threads for the parallelism. Then other concurrency issues, means what are the issues that is available whenever we use the concurrent programming, that is other concurrency issues. So these are the and last one is your summary. So these are the 8 topics that is used or that is covered in this chapter, that is covered in concurrent programming, that is the concurrent programming topic. So let's start with the first of all introduction, that is what is concurrent programming or what is concurrency. First of all, what is the concurrency? This says logical control flows are concurrent if they overlap in time. As I told you, if they overlap in time, that is they are executing more than one at the same time, that is they are overlapping, that is known as the concurrent process. So any flow, any logical control flow are overlapped or concurrent if they overlap in the time. The general phenomenon is known as the concurrency. Shows up at many different levels of a computer system. Hardware exception handler, processes, UNIX signal handler are all familiar examples. These are the various examples, that is hardware exception handlers, different processes, UNIX signal handlers. These are all concurrent processes. Why? Because in their logical flows, that is overlap in the time, that is they are executing at the concurrent, more than one at the same time. Thus far we have treated concurrency mainly as a mechanism that the operating system kernel uses to run multiple application programs. So till now we have treated the concurrency mainly as a mechanism that the operating system kernel uses to run the multiple application programs. But concurrency is not just limited to the kernel. It can play an important role in the application programs as well. That is, it can play important role in the application programs. For example, we have seen how UNIX signal handler allows application to respond to asynchronous events such as user tapping, Control C, or the program accessing an undefined area of virtual memory. Application concurrency is useful in the following ways. So why concurrency is useful? These are the various advantages. That is why concurrency is very useful in any application program or in any application software. So these are the various advantages. The first advantage, that accessing the slow input output devices, that is it is useful whenever we want to access or slow input output devices. This says when an application is waiting for the data to arrive from a slow input output device, that is whenever an application is used or wait for a data to arrive from a slow input output device such as disk, the kernel keeps the CPU busy by running other processes. So this is the main motto, this is the main advantage. Concurrent means more than one process are executing at the same time by the CPU. So if an application needs the data and that data is not available at the runtime, at the current time, so concurrency helps that application to deal with another processes, to deal with another part. Why? Because they keep the kernel or they keep the CPU busy by running the other processes. Individual applications can exploit concurrency. Then individual applications can exploit the concurrency in a similar way by overlapping useful workflow with the input-output request. So this is the scenario how to access or how to why we are using the application concurrency, application level concurrency. Then next advantage is that interacting with the humans, that is the main advantage or the next advantage, that why there is the importance of the concurrency in the system. It is used for the interacting with the humans or useful for interacting with the humans. This says people who interact with computers demand the ability to perform multiple tasks at the same time. As I am a user, I demand that I am able to use the internet, I am able to use the Word, Excel, PowerPoint at the same time. Means more than one processes are executing at the same time. That is, it is the ability to perform multiple tasks at the same time. For example, they might want to resize a window while they are printing a document. Modern window systems use concurrency to provide this capability. Each time the user requests some actions, a separate concurrent logical flow is created to perform the action. This is very useful concurrency whenever the user or the human being wants to interact with the system. That is, when the person wants to access more than one system at the same time, that is the main advantage of using the application level concurrency. Then next advantage is that it reduces. It means concurrency reduces the latency. Latency means any delay by deferring the work. Sometimes application can use the concurrency to reduce the latency of certain operations by deferring other operations and performing them concurrently. That is, if there is any delay in the operation, it is a role of the concurrency, it is a role of the CPU to use another process at the same time, so that there is no latency between the processing in the CPU. There is no time delay, because there are more than one processes. So if the time is so busy, then that process is shifted to the next process, so that there is no time gap between these executions of the processes. Then next advantage is that servicing the network or servicing multiple network clients. That is, it is also important, or concurrency is also important to serve the multiple network clients. That is, if the multiple network clients are executing, or more than one clients are servicing, or more than one clients are requested for a service, that is, when there is a concurrency method, or when there is a concurrency control, so multiple clients can access the data at the same time. So concurrency also serves the multiple network clients. A better approach is to build a concurrent server that creates a separate logical flow for each client. This is the iterative network server that are unrealistic, because they are only provides one client at a time. That is, there is only one server that handles, or that is used for one client at a time. So if I am using the concurrent server, that is more than one server, so they are able to cope up, or they are able to service or serve the multiple clients at the same time. Next point says computing in parallel on multiple or multi-core machines. That is, many modern systems are equipped with the multi-core processor. That is, in nowadays computer systems are equipped with the multi-core machines, with the multi-core processors. So whenever there is a concurrency, it is faster, or the computer is faster, and the multi-core machines are used for the uniprocessor machines, because the flow is executing in the parallel rather than the interleave. So these are the various advantages that what are the advantages why we are using the concurrency. Applications that use application level concurrency are known as the concurrent program. So if there is any application that uses the concurrent processes or concurrency, that is known as the concurrent programs. Modern operating system provide three basic approaches for building the concurrency programs. So these are the various advantages, and now let's take three approaches for building the concurrency methods. That is, these are the three main methods that how to build, or how to approach, or how to use the concurrency in the application. That is, by using the processes, that is by using the input-output multiplexing, that is by using the threads. These are the main three approaches that is used whenever we use the concurrency. That is how, this is the way how the concurrency is maintained in the system. So these are the three methods, and these three methods are the only topic, or the only chapter. That is, these three topics are covered in detail, like this one with processes. The next part is with input-output multiplexing. The next part is with threads. That's all. This is the only chapter, or this is the only topic that is covered in this chapter. So this says, with this approach, each logical control flow is a process that is scheduled and maintained by the kernel. That is, every logical control flow, or each logical control flow is a process that is scheduled and maintained by the kernel itself. Since processes have separate virtual address space, flows that want to communicate with each other must use some kind of explicit inter-process communication mechanism. That is, the processes, or the process uses the IPC mechanism whenever there is a concurrency with the multiple processes. That is the inter-process communication. Then next is your input-output multiplexing. This is a form of the concurrent programming where application explicitly schedule their own logical flows in the context of a single process. That is, this is the application, this is the way, or this is the form when or where different applications exploit the schedule or maintain the schedule for the logical control flow. Then next is how to maintain the concurrency with the help of threads. And threads are the logical flows that runs in the context of a single process and are scheduled by the kernel. This chapter investigates 3 different concurrent programming techniques. To keep our discussion concrete, we will work with the same motivating application, a concurrent process of the iterative echo server. So let's start with the first topic, that is concurrent programming with the processes. But before this, let's take a quick review in the slides, that is what is covered in the slide. This is chapter number 11, that is concurrent programming. The first topic is your concurrent processes. That is how different processes are executing at the same time. First of all, there is an introduction. That is more than one operating system, not more than one. That is modern operating system can handle more than one process at a time. That is modern operating system means that the day-to-day operating system like i3, i7, i5. So these are the modern operating system that can handle, that is able to handle more than one process at a time. System scheduler that schedules the time, manages different processes and their competitions for the CPU. That is, the system schedulers manage different processes and their competition for the CPU. Then next, memory manager role is to manage sharing of main memory between the active processes. So one is the role of the system scheduler that manage the various processes, and one is the role of the memory manager that shares the main memory between the different active processes that are operating or that are executing at the same time. Looking at how processes coexist and communicate with each other on modern computer. That is how different processes coexist with each other and communicate with each other on the modern computers. What is the advantages and what are the disadvantages of using the concurrency, that is pros and the cons. So one of the one of the advantages is that concurrency is good for the users. That is, concurrency is very good, or concurrency is good for the users who is using the system. One of the reasons for multi-programming. This is one of the reasons how multi-programmings are used. That is, if the computer or if the system supports the multi-programming, then it is good for the multi-programming. That is, more than one programs are executing at the same time. Working on the same problem, simultaneous execution of programs, background execution. That is, we can work on the same problem again and again. Simultaneous execution as well as the background execution is take place whenever we use the concurrency. Next is concurrency is a pain in the neck for the system. That is, pain in the neck means why this is a limitation, why concurrency is a limitation. First of all, we have studied what is the advantage. That is, with the help of multi-programming we use the multi-programming. What is the advantage? That with the help of concurrency we use the multi-programming. Then what is the disadvantage? That it is a pain in the neck for the system. Why it is a pain in the neck? Because it is used for accessing or access to the shared data structure. That is it is useful for accessing the shared data structure. Then deadlock due to resource contention. That is, deadlock is also maintained. That is, deadlock is also available whenever there is a concurrency. Why deadlock? Because more than one processes are fighting for the same resource, So there is a deadlock condition in the system, in the computer. Then enabling the process interaction. That is, it also the limitation is also that it enables the process interaction among each other. So there is no security among the processes. This is also the limitation, that is a concurrence or cons of using the concurrency. Now concept, what is a process? A process is a program in the execution, that is any program that is in execution, that is known as the process. A process has a state including resources like memory and the open file. So every process in the computer has some states, have some values including, or that includes the resources like memory, open files, as well as the contents of its program counter, that is a PC, that is a program counter. This is a process execution context. So one is a process, one is the program counter that counts the value or that is used for the next instruction, that holds the address for the next instruction. This is the process execution context. Next point says a concurrent program has more than one execution context. That is, if I am using the concurrency, that it contains more than one execution context. This type of program is also referred as a multi-threaded program. That is, whenever more than one programs are executing at the same time, that is concurrent execution of the programs is available, that is known as the multi-threaded program. Then one is the parallel program, that is also a concurrent program with more than one thread executing simultaneously. Now what is the relationship between the processes, or what are the types of relationship between different processes? One is fully independent, that is separate applications running on the one machine, that is the fully independent, that is different processes are running on the same machine as a separate entity. Then independent but related, that is they are independent but they are related with each other. Example, user running their own copy of a data entry program but accessing and updating the one database. Then concurrent processes, that is also the relationship, that is the concurrent processes between the different processes, that is the set of cooperating the processes. Now what are the resources that is available or that is used for the concurrency in whenever there is a concurrency in the process? Now first of all, let's deal with the help of the book. This is concurrent programming with the processes. This is the simplest way to build a concurrent program is with the process. That is, the simplest method to build the concurrency programming in the computer is done by using the processes, using the familiar functions such as fork, execute, wait, PID. That is the simplest way to build the concurrent programming with the processes, using the various functions, that is either using the fork, either using the execute, either using the wait, PID. For example, a natural approach for building a concurrent server is to accept client's connection request in the parent and then create a new child process to service with the each new client. That is, this is the example, that is a natural approach for building a concurrent server is to accept the client connection and then create a new child process. To see how this might work, suppose we have two clients and a server. That is, there are two clients and there is only one server that is listening for connection request on the listening descriptor. Now suppose that the server accepts a connection request from the client 1 and returns a connected descriptor, that is say 4 as shown in figure 1. This is the figure 1. Client, there is a client, there is a server. Client approaches to the server, there is a connection request, then it is using the listen FD, that is the file descriptor. One is using the connection FD, that is the connection file descriptor. After accepting the connection request, so first of all connection request is sent. After accepting, it accepts the connection request. The server forks a child, that is server creates the child, which gets a complete copy of the server's descriptor table. That is, it forks the child so that it contains or it gets a complete copy of the server's descriptor table. Then the child closes its copy of listening descriptor 3, that is it closes of listening 3, and the parent closes its copy of connected descriptor 4. This is the example how this is maintained. since they are no longer needed. This is the way one is connection is maintained, then it is removed by the listening, the listen FD is removed, that is the file descriptor is removed. Why this is removed? Because it unnecessarily shares the memory or use the memory, so there is no use. That's why it releases the listen FD, and then the client also releases the connection FD because connection is already maintained. Next point says, or the next line says, since the connection disk or connected descriptors in the parent and the child each point to the same file table entry, it is crucial for the parent to close its copy of the connected descriptor. Otherwise, the file table entry for connected descriptor will never be released. Now suppose that after the parent creates the child for client 1, it accepts a new connection request from client 2 and returns a new connected descriptor as shown in figure 3. This is server accepts another connection request. First of all, there is a data transfer between the child and the client. There is a connection. Then in this there is a server that accepts another connection request, that is client 2. This is example. Server forks a child process. There is a data transfer. There is a server that forks a child process by using the listen FD3. Next point or the next topic says a concurrent server based on the processes. That is figure number 5 shows the code for a concurrent echo server based on the processes. That is, first of all, server typically runs for long period of time, so we must include a signal child handler and then leaves the zombie children. This is the server forks another child to service the new client. Figure number 5. This is the figure number 5, how echo will be maintained or how echo server will maintain the clients. Now what are the pros and the cons of the processes? That is, what is the benefit and what are the advantages and disadvantages of processes. Now let's see with the help of book. This is what are the resources that is available for the concurrent programming, that is using the processes. This says, first of all, there is a process complete for the CPU, that is memory is required, input output devices is required, and secondary storage is required. Other resources may include data items in main memory such as message queue, shared data structure. Then resources can be reusable or consumable. Reusable examples are CPU, main memory. So these are the resources that is used, that is the reusable resources as well as the consumable resources that is created by the one process and consumed by the another process. That is message sent between one process and the another. Then what is a mutual exclusive, or what do you mean by mutual exclusive? It is necessary for some resources to remain allocated to a process for so long as process require. That is, in simple terms, whenever we are using multiple processes, there are some processes that remains the resources or that retain their resources as long as process is in use. Serial reusable resources require mutual exclusion. Example, printer is being used by the processes, then it must remain allocated to the process until printout is complete. Mutual exclusion gives rise to another problem which operating system must handle, that is the deadlock. So deadlock is also a problem that is created by the mutual exclusion. Deadlock is a situations where a process is waiting for an event that will never occur. This is the scenario of the deadlock. P1 holds the paper for the printout, waiting for the file. P2 is also holding the file, waiting for the printer. That is, both the P1 and the P2 process is giving the print command at the same time. That is a deadlock condition. Now, mutual exclusion first attempt, that is busy waiting. Process is always checking to see if it can enter the critical section, that is if it is busy or not. Process can do nothing productive until it gets the permission to enter its critical section. Now, what is a coroutine that is used, that is designed to be able to pass execution control back and forth between themselves. That is inadequate to support the concurrent processing. Now, what is the second attempt? That is the first attempt. Second attempt is that each process can examine the other status but cannot alter it. When a process wants to enter the critical section, it checks for the other processes first. So first of all, suppose there are 4 processes and P2 wants to going into the critical stage. So first of all, it checks the other processes as well. That is, other processes needs the resources or not. If the other processes need the resources, then that process, that is the P2 process, must retain their processes or must close their connection and maintains the new connection after P4, that is the next process, or the next process that is currently executing is executing or over the execution. Now, third attempt is set the flag to enter the critical section. So one is don't go to the critical section. Next attempt is set the flag. So that flag will be maintained, approach will be maintained, a target will be maintained. So set the critical flag to the critical section before check the other processes. If another process is in the critical section, when the flag is set, the process is blocked until the other process releases the critical section. And this is one of the important concept, that how different critical sections or different processes can execute the processes. Deadlock is also possible when 2 processes set their flags to enter the critical condition. That is, if more than one processes set their flag, so there is also deadlock condition, so that different critical functions are used. Now each process must wait for the other process to release the critical section. Now what is the fourth attempt? A process sets its own flag to indicate it desires to enter its critical condition but is prepared to reset the flag. That is the next condition, that is the important one, that is the next attempt, that is the process itself maintain the critical condition, itself maintain the flag to desire to the critical condition so that it might not be used or may not be used, and prepare to reset the flags. Other processes are checked. If they were or if they are in the critical region, the flag is reset and the later set to indicate desire to enter the critical region. Now it is also possible for each process to set their flag, check the processes. In simple terms, these are the various attempts how these shared resources will be accessed by the one process only. What is the correct solution? The correct solution is that each process gets a turn at the critical section. That is, every process that gets a turn at the critical section. If a process wants a critical section, it sets its flag and may have to wait for its turn. That is, if the process wants to go to the critical section, that is using the resources, using the pointers, then first of all it sets the flag and wait for its turn, that is using the critical sections, or that is going into the critical section. So what do you mean by the critical section or critical region? So any area of a process which is sensitive to the inter-process complication, that is any area that is within the region of the inter-process complication, that is known as the critical region. To guarantee that mutual exclusion, only one process is allowed to enter its execution process. Operating system needs a system or system to ensure that process cannot enter the critical region if another process is in it. That is how OS needs a system, how OS needs or maintains a system by using the semaphores, That is mutual exclusion with busy waiting. This is the process A. A enters the critical region. B attempts to enter the critical region over here. A leaves the critical region, now B enters the critical region. Why? Because A is already entered the critical region. So B does not allow, operating system does not allow the B to enter the critical region. So when the A leaves the critical region, now it's a time for the B to enter the critical region at the time interval, that is T3. Again B leaves the critical region. 4 conditions to provide the mutual exclusion. That is, these are the 4 conditions that is used for using the exclusion or for using the mutual exclusion. That is, no 2 processes simultaneously in the critical region. Agree? Why? Because if 2 processes are in the critical region simultaneously, then there is a hosh-posh, then there is a difficulty that no process will share or no process can access the resources of the CPU. That is the main disadvantage. Next condition is that no assumption made about the speed or the number of CPU. That is, there is no assumption that this is the, I think this is the speed of the CPU. No, you want the exact figure. Why exact figure? Because that sharing or that CPU sharing is very limited. That is shared by multiple processes. So if you assume something, so that goes into the loss. Then next point says no process running outside its critical region may block another process. So as I told you, one process can block the another process. And what is the condition? Why one or when one process holds the another process? Whenever it going or it is going in the critical region. Means any process that is beyond the critical region cannot block the another process. Next point says no process must wait forever to enter its critical region. That is, no processes must wait forever to enter its critical region. Every process has a turn to enter to the critical region. Now, what is a semaphores? That is how inter-process communication is done by using the semaphores. This is, semaphore is a system of communication using the flags. That is, whenever we set the flag for the processes so that 2 processes never overlap with each other, that using the flags or that communication by using the flags is performed by the semaphores. So it is a system of communication using the flags. There are 2 stations, a sender and a receiver, and they must be able to clearly see the other station. For long distance communication, there could be a number of repeater stations between the sender and the receiver. That is, for a long distance, for a larger distance, there could be a number of repeaters that is used for the communication, that is used for interaction between the sender and the receiver. Generally, a station consists of 2 people. Semaphores means maintaining the flags between the sender and the receiver so that one can see the another station at the clear stage, and the repeaters are used for increasing the speed between the sender and the receiver. This is the theory of the semaphore. That is how semaphores will be used. Next, semaphores in the software. That is how it will be used in the software. One is Edexcel algorithm that is used in 1965, proposed or uses the semaphores as a solution to the problem of the concurrent processes. So one solution of the concurrent processes is using the Edexcel algorithm that is available in the 1965. The fundamental principle is that 2 or more processes can cooperate by means of simple signals, such as a process can be forced to stop at a specific place or specified place until it has received a specified signal or specific signal. That is, at any moment of time it can replaces or it can or more than one processes can cooperate with the multiple signals or with the multiple scenarios with multiple places. Then for signaling, special variable that is known as semaphores are used. There are 2 types of signals that is used. One is signal S, one is wait S. Signal S is used to transmit a signal and wait is used to receive a signal. So signal is used for sending the signal, wait is used for receiving the signals. So in simple terms, whenever we use the semaphores, that maintains a separate flags or separate processes. Next, file and record locking. That is next concept, how mutual exclusion is required or maintained by using the file and the record locking. That is, file will be locked and the record will be locked so that no one can access or no one can enter into the critical section. This says mutual exclusion is required file processing where several users are accessing the same file. That is, more than one users are accessing that same file, that is a database. Then next is your file and the record locking. That is how file will be locked and the record will be locked. This is mutual exclusion is required file processing where several users are accessing the same file. That is, mutual exclusion is required. Mutual exclusion is required whenever there is a need or whenever more than one process or servers or users are accessing the same file, same database. Example is airline booking system. One seat left, two agents access at same time before file is updated and seat is double or booked double or double booked. This is the best example. So only one seat is left, but there are two persons, both can access at the same time, and before the file is updated and both the persons are updating or both the persons have a same seat, that is seat is double booked. Solution is the file locking, preventing access to the file while it is being updated. That is, if I'm reserving the tickets for the airlines, then if I already booked the seat, then that seat will be locked before it can be updated in the file, because there is a time gap between the when we reserve the seats and when the file can be updated by the administrator. So there is a time gap. So if there is a locking mechanism, then when I reserve the airline seats, then suddenly that seat will be locked. That seat will be locked by using the file locking and the record locking. That is the solution, or that is the way how file locking. In the same way, the file locking and the record locking is maintained in the concurrency control. That is, file will be locked so that no other user can access or share that file, because file can be locked already. So that should be maintained by using the file locking and the record locking. Then what are the types of the file locking? How we can maintain the file locking? So one is your file lock. File lock means the file will be locked, that is the whole file is locked, prevents any other process accessing any part of that file. That is, whole file, that is a full file will be locked and prevent the other processes or prevent any other process accessing any part of that file. One is your write lock, that is, if a specified set of data is write locked, that prevents the other process from modifying or reading the data. One is your file lock, that is the read only mode, that is only the process can access any part of the file, that is prevents the process from accessing any part of the file. One is writing, that prevents the process by modifying or reading the data. One is read, that is used, or that is set of data that is read locked. Other processes may read data but no process can modify it. So one is file, one is write, one is read. These are the three types of locking that is available. Now let's see with the help of the book. These are the pros and the cons of the processes, that what are the advantages and what are the disadvantages. This says process have a clear model for sharing the state information between the parent and the children. That is, there is a sharing between the parent and the children for sharing the information, that is a state level information. On the other hand, separate address spaces makes it more difficult for the processes to share the state information. To share the information, we use the IPC mechanism, that is a inter-process communication mechanism. Another disadvantage, another drawback of this design is that they tend to be slower because the overhead for the process control and the IPC is very high. Means, what are the disadvantages why we are not using the IPC? Because there is a high cost that is required for using the IPC. So in simple terms, if a question arises, what is a IPC? So this is IPC is a technique that allows the different processes to communicate with other processes that are running on the same host. That is, if there are 4 clients that is running on the same server, then IPC means the inter-process communication that is on the same server. If there are 4 clients, that 4 clients can communicate with each other. That's why it is known as the inter-process communication. That is, within the server, different processes, different clients can communicate. That is a technique for communication between the different processes, but on the same server. The condition is that on the same server, on the same machine. Now, next topic is your concurrent programming with input-output multiplexing. This is the same input-output multiplexing. So first of all, let's take 5 to 10 minutes break, then come back starting with this topic, that is concurrent programming with the input-output multiplexing. So let's take a break, then come back starting with the concurrent programming with the input-output multiplexing. Now let's start with the next topic, that is the concurrent programming with the input-output multiplexing. So till now we have covered how to maintain or how to perform the concurrent programming with the processes. That is, more than one processes are there and there is a concurrent programming among these processes. Now next approach is that how to use the concurrent programming with the input-output multiplexing. That is, more than one inputs are available, more than one outputs are available, then how different inputs and outputs are multiplexed, are clubbed together into a concurrent programming. So let's start with this topic. This is one of the interesting topic, not the easy but the interesting topic. This is, suppose you are asked to write an echo server that can also respond to interactive commands that the user types to the standard inputs. That suppose there is a requirement that you are asked or you are able to or you are supposed to to write an echo server, that is for writing an echo server that can also respond to the interactive commands that the user types to the standard input. So requirement is that maintain a server or write a server that is respond to the server, that is respond to the performance that is maintained by the concurrent programming. In this case, the server must respond to 2 independent input-output events. Means in this case, in this scenario, the server requirement is that, or server need is that to maintain or to respond to the 2 independent input-output devices. What are the 2 independent input-output devices? One is a network client that makes a network connection, that makes a connection request. One is a user that type a command line at the keyboard. That is, one is using the network client that is used for the connection purpose, one is using the user, or one is having the user that is typing a command line at the keyboard. Which event do we wait for the first? Neither option is ideal. If we are waiting for a connection request, then we cannot respond to the input request. Similarly, if you are waiting for an input command, then we cannot respond to any connection request. So both are required at the same time. That is, connection is also required and the typing or the input is also required. So we cannot maintain or we cannot make the comparison between these two. That is, connection is also required and the input is also required. So one solution is that using a technique that is known as the input-output multiplexing. That is, at the same time connection is maintained, at the same time input is also given. The basic idea is to use the select function to ask the kernel to suspend the process. That is, the basic idea or the general idea is to select the or is to use the select function to set the or to ask the kernel to suspend the process. Returns the control to the application only one or more input-output events have occurred, as in the following examples. So this is the event that is occurred, that is for the following example, which is the event that returns when any descriptor in the set 04 is ready for reading. Returns when any descriptor in the set 1 to 7 is ready for writing. Timeout if 152.13 seconds have elapsed waiting for an input-output event to occur. So these are the various examples how these input output events can be controlled in an application. Select is a sophisticated or complicated function with many usage scenarios. We will discuss the first scenario, that is waiting for a set of description that is ready for reading. That is for reading purpose only. This is the example that is used, that is hash includes unistd.h, that is using the header file, using the sys types.h, then use the int select, give the arguments, that is n, fd set, that is a file descriptor set, fd set, null null null, that returns a non-zero count of ready descriptors, and -1 on the error. Then there is a fd0, then there is a file descriptor 0, then there is a fd clr, that is a fd file descriptor clear. One is fd set, that is a file descriptor set. Then fd is set, that is the if the fd is set or not, that is the challenge, or that is the requirement. Then fd0 means clear all the bits in the fd sets, then clear bits in the fd set. This is also used for clear, this is also used for clear, this is used for setting the bits, that fd set is used for setting the bits, that is setting the file descriptor, that is used for the file values. Then is set, that is set is used is bit fd is fd or not. These are the various requirements, that is how different multiplexing should be maintained. This is not even used, simply maintain that select function manipulate the set of type fd set which are known as a descriptor set. The best way is to understand select is to study a concrete example. This is the example that is not in your course. This is very typical example. Yeah, this is the example, or this is a program coding that you have to study. This says once select returns, we use the fd is set macro to determine which descriptor are ready for reading. So one is used for reading, one is used for writing, one is used for determining which descriptor is used for the reading, which descriptor is used for the writing. If the standard input is ready, we call the command function which reads, parses and responds to the commands before returning to the main routine. If the listening descriptor is ready, we call except to get a connected descriptor, then call the echo function from the from figure 21 of the chapter, that is network programming, that echoes each line from the client until the client closes its connection. So use the figure 21. Figure 21 of the chapter network programming, that is the next topic. Now let's see with the help of PPTs. Input output multiplexing. This says, first of all, what is input output multiplexing? So this says when an application needs to handle multiple input output descriptor at the same time, that is known as the input output multiplexing. That is, when an application, when an software needs or uses or needs to handle the multiple input output descriptor, that is using the FD at the same time, more than one FD at the same time, more than one input at the same time, more than one output at the same time, that is known as the input output multiplexing. For example, file and the socket descriptor, that is a file descriptor, socket descriptor, multiple socket descriptor, that is the input output multiplexing. Next point says when input output on any one descriptor can result in the blocking, that is any one descriptor can result in the blocking. This is a non-forking concurrent server, that is there is no fork call, or there is no fork function that is used, that is more than one function or more than one client uses the same server with the different file descriptor, that is the file descriptor is different but the server is the same and there are different clients. So at the lowest bar there is different clients, C1, C2, C3, C4, C5. There are different sockets like FD1, FD2, FD3, FD4, FD5. and there is only one server. That server is using the function that is known as the select function. Then there is a listen FD that is used for listening with the server. So for everything there is a different file descriptors. Then these are the input output models that is used. One is blocking, one is non-blocking, one is input output multiplexing that is done using the select function. One is signal driven input output, one is asynchronous input output. This is blocking input output. There is an application, there is an operating system. This is received from the process, or process block has received the datagram for the process. There is a system call, that is no datagram is ready, waits for the data. Now datagram is ready, copy the datagram, copy the data to the user, then copy is complete. Then return to the OK, process the datagrams. This is how blocking will be maintained. This is the non-blocking scenario, this is the input output multiplexing. This is received from function is used, that is the system call, that is no datagram ready, that is E would block. Then received from, there is a system call, there is a E would block, that is no datagram is ready. Then received from, that is the system call, datagram is ready, copy the datagram, copy complete, return OK, process the datagram. Then this is the example of the input output multiplexing that is done using the select function. How select function will be used to process the different blocks, and one more function that is used is received from, that is used for processing the blocks, that is received from another block. So two functions are generally used. One is select, one is input output. One is select, one is received from. So this is process block, this is the process datagram. Then there is a system call, that is no datagram is ready, wait for the data, datagram ready, return readable, system call, return OK, the same example. This is the signal driven input output. The same way, there is establish a signal, that is a signal input output signal handler that continues the process, or that calls the function, that is the system call, that waits for the data, then copy the data, return the OK if the process datagram is OK. Then asynchronous input output, that is using by using the function, or that is used by using the function, that is AIO read, that is the asynchronous input output read function that is used for reading the asynchronous values. Then now it's a select function. Now there is a concurrent event driven or event driven server based on the input output multiplexing. This says input output multiplexing can be used as the basis for concurrent event driven or event driven programs, where flows makes a progress as a result of certain events. The general idea is to model the logical flows as a state machine. Informally, a state machine is a collection of states. That is, this point says whenever we use the concurrent event driven server, that is also based on the input output multiplexing, that is using the state machine that contains various states, various input events, and the various transitions that maps the states and input the events to the different states. A self loop is a transition that is maintained between the same input and the output state. And the state machines are typically drawn as a directed graph, where nodes represent the states, directed arcs represent the transitions, and the arc label represents the events. This is the state machine for a logical flow in a concurrent event-driven eco server. There is a state that is waiting for a descriptor, that is DK to be ready for reading. There is a transition, one is input event. So this is the input event that is ready for writing. One is transition, that is read a text line from a descriptor, that is DK. Then again this is the same. The select function is used to detect two different kinds of input events. That is a connection request, that is a connection or connected descriptor. So one is connection request, one is connected descriptor. Next function that is used is the init pool function that initializes the client pool. One is add client that added the new client. So in this you have to study only the these functions names as well their role. The check client function echoes a text line from each ready connection or each ready connected descriptor. This is the example in the C language. This is the init pool example. Then there is a check example that how to add the client. This is used for checking the check client. Now, what are the pros and the cons of input-output multiplexing? That why we are using the input-output multiplexing, and what are the pros and the cons of the input-output multiplexing? Now, let's see with the help of the slides what are the pros and the cons. This is, first of all, there is a select call that allows the process to wait for an event to occur on any one of its descriptor. That allows a process or that makes a process that is waiting for an event to occur or any one of this descriptor. What are the types of events that is available? One is ready, that is read operation, one is write operation, one is exception operators condition. And this is the example of the select call. Then use the struct fd set, then that is using the next function that is a struct fd set, that is a file descriptor set. That typically holds the 256 descriptor states. Next is your server that is maintaining the fd set, rd set and the wr set. One is file descriptor set, one is read set, one is write set. Then high resolution timer that is done by using the select function, by using the sleep function. Now next is your socket options. What are the three socket options? That is how to manage the sockets. Three options are available. One is get socket opt, one is set socket or sock opt. So one is get sock opt, one is set sock opt, one is FCNTL, one is IOCTL. These are the three ways or the three socket option that is used. Then again these are the various codes that is used for the various socket commands. One is get socket opt, one is set socket or set sock opt, and these are the various socket options that is available. That is SO broadcast that enables the socket for sending the broadcast. Then SO keep alive that regularly probes or that regularly checks whether there is any inactive TCP connection or not. Then SO linger that lingers till all the data is sent before returning or before returning from close function or a TCP connection. Then SO RCV buffer that is used for sending and receiving the buffers on the socket. One is SO RCV time, SO SND timeout that is places the timeout on the sending and the receiving the application or operation. These are the various socket options that is used in the socket programming, that is used in the concurrent programming when we are using the concurrent programming with the input-output multiplexing. Next is your FCNTL that is using the FCNTL. This is the scenario, this is the syntax, not the scenario. This is the syntax that is using. These are the arguments. One is FD, one is CMD, one is ARG. Next, miscellaneous file control operations. That are what are the miscellaneous file control operations? One is non-blocking input output, one is signal driven input output, one is set socket owner. Now let's see what are the pros and the cons of the input-output multiplexing. Now let's discuss what are the pros and the cons of the input-output multiplexing. That is, what are the advantages and the disadvantages of input-output multiplexing. This is the server in figure 3 or figure 8. Now, what is figure 8? This is the figure 8. That is the eco server based on the multiplexing. That is the server in figure 8 provides a nice example of the advantages and the disadvantages of event-driven programming based on the input-output multiplexing. Now, one advantage is that input-driven designs give the programmer more control over the behavior of their programs than process-based design. So this is the main advantage, that whenever we use the event-driven designs, that gives the programmer more controllable, that gives the programmer more control over the behavior of their program than the process-based design. This is the main advantage. For example, we can imagine writing an event-driven concurrent server that gives preferred services to some clients, which would be difficult for a concurrent server based on processes. So this is the advantage, or this is the example, that assume that event-driven concurrent server gives the preferred services to the some clients, which would be difficult for the concurrent server based on the processes. That is, they provide the better services to the clients than when we are using the concurrent server or when we are using the process-based design. Another advantage is that event-driven server based on input-output multiplexing runs in the context of a single process only, and therefore every logical flow has access to the entire address space of the process. That is, every process or the logical flow is running only for the one process. The logical flow is running for the entire address space of the process, because there is only single process that is using the processes. So that is only single or access the entire address space of the process. That makes it easy to share the data between the flows. These are the advantages, that is, sharing is very easy. Next advantage is that running a single process is that you can debug your concurrent server as you would any sequential program. That is, it is very easy to debug the process. It is very easy to debug the server when there is only single process by using the GDB. By using the GDB. That is a GDB debugging tool that is used for debugging the technique. Now, what are the cons of the input-output multiplexing? That is, what are the limitations of input-output multiplexing? This is a significant disadvantage of event-driven design is coding complexity. That there is a high number of coding, because you see there are multiple functions. One is initB, one is echo function, one is the echo server. So there are different functions. So there is a large number of coding. So disadvantage is that this design requires, or this design has coding complexity, that is more coding is required. Our event-driven concurrent eco server requires 3 times more code than the program or the process-based server. That is, whenever we use the eco server, whenever we use the event-driven concurrent server, then that requires 3 times more coding than it is required by the process-based server. Unfortunately, the complexity increases at the granularity of the concurrency decreases. By granularity, we mean the number of instructions that each logical flow executes per time slice. That is, number of executions, number of instructions that can execute at a time, that is known as the granularity. Another disadvantage is that it cannot fully utilize a multi-core processor. So advantage is that sharing logical flow. Disadvantage is that code complexity and the unutilization of the multi-core processes. Now this is the next concept, next topic, that is concurrent programming with threads. This is the topic that I will be starting in the next class, that is the tomorrow's class, that is how to use the concurrent programming with the threads, because there is no time left, only 5 to 10 minutes is left, so it is no use to start the new topic. So let's start the next this topic in the next class, that is the concurrent programming with the threads. Till now we have discussed how to use the concurrent programming with the processes and how to use the concurrent programming with the input-output multiplexing. Next concept is how to use the concurrent programming with the threads. So let's see what is left in the PPTs. This is done. This is done. Okay, thank you. So that's all for today's session. Thank you so much everyone. Now if you have any questions, then please text the question. I will answer you. But before this, let's take a quick review what we have covered, or just a quick 2 minutes review what we have covered in the today's class, so that you can clarify if there is any doubts. So let's start what is covered in the today's class. We have started with the chapter number 11, that is the concurrent programming. We have discussed about the concurrent processes, that is how to use the concurrent programming with the processes, with the help of processes. We have discussed about the introduction, that is what is operating system, how we can schedule, or how operating system schedule the processes, how memory manager manages the memory between the different processes. Then what are the pros and the cons of the concurrency. Then we have discussed about different concepts, program counter, process. Then we have discussed about the relationship between different processes and what are the resources that is used for processes. Then we have discussed what is a mutual exclusion, how we can use the mutual exclusion. Then what is a deadlock? Deadlock means a condition where there is no resource, that is where there is a single resource that is shared by multiple processes. This is again the process. This is the mutual exclusion first attempt. That is a problem, or that is a first attempt that is used in the mutual exclusion. Multiple attempts are used. Then we will discuss about the coroutine, second attempt, third attempt, fourth attempt. Then correct solution. What is the correct solution after taking these attempts? Then critical reason, that is what is the critical reason that is used, or what is the critical reason, how different processes is going to the critical reason, and how different processes overlays the time in the critical reasons. Then we will discuss what is the semaphores for communication, that is done by the IPC. Then how to discuss, or what is the file and the record locking, we have discussed. Then we have discussed what are the types of the file locking, that is the file lock, read lock, write lock. Then we have discussed about the next topic, that is the concurrent programming with the input-output multiplexing. That is what is the input-output multiplexing, fork server, input models, blocking input-output, not blocking input-output, what is the input-output multiplexing, signal-driven input-output, asynchronous. Then we will discuss about system different functions, that what is a system call that allows a process to wait for an event if there is any, or if there is any event occur. Then this is the example of the select call. Then we will discuss about the new function, that is the struct fd set, that is set the file descriptor that is used for the communication between different processes. Then non-forking concurrent server, that is how to use or how to set the, or how to maintain the connection for the non-forking concurrent server. This is the example. Then high resolution timer. Then we will discuss about the high resolution timer. Sleep function is used for the resolution of the seconds. Then we will discuss about the socket programming and the socket option that is available. 3 ways are used for the socket options, for manage the socket options. One is get socket opt or get sock opt, one is set sock opt, one is FCNTL, one is IOCTL. These are the concepts, these are the code that is used for the get sock opt, one is used for the set sock opt. Then these are the various socket options that is available, that is broadcast, keep alive, linger, RCV buffer, RCV timeout. Then next function that is discussed is the FCNTL. So that's all for today's session. Thank you so much everyone. If you have any questions, then please text the questions and I will answer you. In the tomorrow's class, I will be starting with your next topic that is your concurrency programming with the threads. That is how concurrency programming is maintained with the help of the threads. So that's all for today's session. Thank you so much everyone, and bye bye everyone.